Oh, I'm sorry. What is 75 degrees in radians?
3/4 pi.
What fraction of pi is 75 degrees?
Hold on.
Raise your hand if you know.
Hold on.
Andy.
5/12 pi.
5/12. So 15 degrees is 1/12, and this is 5/15, so it's 5/12. What is 20 degrees? Someone else.
Oh, what?
I still don't know the whole name.
2/9 pi.
Same
thing.
Julian.
Pi/9.
I have a 9. 120 out of 180. Yes. A fifth of a revolution. Somebody over here. Fifth of a revolution.
I'm not sure.
Yes.
Hold on. I need to.
Okay. 2/5 of pi. Yes. 1/16 of a revolution.
Pi over 8.
Pi over 8. I was thinking about a quarter of a revolution is pi over 4, and this is half of that. That's sort of how I thought it. I don't feel like saying 1/16 of 360 and have to start canceling and stuff. Here is another chair, and there's one up front. And there's a chair, there's a spot to sit here.
Okay, so with art, they weren't Eric. They didn't bring art, and they were we were like.
Okay, so that's the converting to degrees. 1/5 of a revolution in degrees. What is it? Fifth of a revolution in degrees. 72 degrees. Yes. All right, that's enough on them. If the radius is 5, what is the circumference of the circle?
10 pi.
What's the area of the circle? Okay. If the radius is a half, what's the area of the circle? 1/4 of pi. What's the circumference?
Pi.
Pi. All right. Length and arc length. If the radius is 5, I'll write it on the board. The radius is 5, and the angle is 5/15 radians. What is the arc length, or the length of the curve of the arc? Who said something?
Wait, is that a J?
Where? No, that's 5.
Oh,
My sloppy handwriting.
sorry.
I'm the one to say sorry. Okay, so what is the area? I'm sorry, arc length.
I think you wrote a 5 instead of a pi. Probably 5.
On the angle. You're right, I did. Copied it wrong. Pi over 15 radians for an angle, and the radius is 5.
The arc length was pi over 6.
Pi over 3. If you're using radians for the angle, you find the length by simply multiplying the radius and the angle. Okay? What is the area of the sector? Who has not answered? Annie did these. Okay. Say it again. 5. How did you get that? What's the formula?
Well, I did the hard way.
What was the hard one?
I figured out the angle.
Say it again.
I figured out the angle and I think I did.
Angle in what? In what? In degrees? You convert it to degrees. So what is this in degrees?
All my work is messed up, so.
In degrees. So pi over 15 radians. And then we can multiply by a fraction, which has radians down there. Pi radians is 180 degrees. That's 1. And the radians cancel. And the answer is it's 180 over 15, which is 12 degrees. Is that right? I think so.
Get it now.
15 and 180. So 1 and 32. 12. Yes, 12 degrees. So then what did you do?
Put the degrees in.
So then the area you said was 12 over 360, which is the fraction of the whole circle, times the area of the circle, which is pi 5 squared. And then you canceled a 5. 1 factor of 5 goes in. 5 into 36 is a 72. And 12 over 72 is 1/6. All right, easier. Area of a circle is 1/2 r squared theta. Okay, and so that is equal to 25 for the r squared over 2 times pi over 15, which is, that's a 55 there, sorry, my handwriting. Cancel a 5, cancel a 5. And you get 5 over 6 pi. Okay? If you're working in radians, this is fun. Another way to do it, more like this, would be 2 pi radians in a full circle, pi over 15 radians in what we're doing, times pi 5 squared, which is the area. And rather than converting to degrees and calculating the fraction, you can calculate the fraction directly in radians. Full circle is 2 pi, the piece is pi over 15.
I found
Yes.
a flash drive.
Pardon me?
On a flash drive.
Where'd you find it? Sitting there. I don't know whose it is. Leave it there.
Okay.
How was it there for me?
And so then a 5 cancels, and pi cancels, and you get to the same answer. Okay? All right. So that's that one. And then what's the last? Now we come to trig functions. 5, find all 6 trig functions for the angles which intersect the circle at the given radius. And given. So we have a point on a circle over here. We have a circle. Here are the axes. We have a point -8, 6. So -8, 6. There is that. And then the Pythagorean theorem tells me the length of the diagonal is 10. So the radius is 10. It was given. Better be correct though. Okay? And you wanted to know the 6 trig functions of this angle. Sine theta, cosine theta, tangent theta, cotangent theta, secant theta, cosecant theta, equals. What is the sign? Everybody, loud, out loud.
Sit over, Jason.
It is, sine is opposite over hypotenuse.
Height over the diagonal. What about the cosines?
-8 over 10.
8 over 10. If you want to reduce it, it's 3/5, and this is -4/5. How about the tangent?
3/5 over -4/5.
Yeah, which is negative 4. Negative 4.
which you can do directly in terms of the sides, which are 6 and minus 8, which is 6 over minus 8, which is minus 3/4. You can do it taking sine over cosine also, and the 5's cancel off. Okay? Cotangent is,
Negative 4.
that's easy because you just turn that one upside down. What's secant?
Negative 5/4.
Negative
You're just turning that one upside down. And the cosecant?
negative 5/3.
5/3.
No, negative.
5/3.
5/3. Okay. Because you're turning this one upside down. Now you will notice that sine squared of theta plus cosine squared of theta is equal to this one squared. 9 over 25 plus 16 over 25. Notice squaring the minus goes away, right? And that adds up to 25 over 25, which is 1. Okay? Okay, here's a little quiz, pop quiz. There is an identity involving secant squared theta and tangent squared theta with an equal sign between them, and you need to add a 1 somewhere. Plus 1, plus 1. Which one is correct? Answer A or answer B? Which side do you add the 1 to make it correct? Pardon? B. Why?
Why?
And you remember the answer. Okay. Other people who didn't remember the answer.
Well,
Okay.
you
Yes? Speak up your complaint or
I don't like it how people answer way before I'm equal to, so it's like,
Okay. Think about it. Give me your idea on this. How would you figure out which side needs the 1? Any of you remember how we got it?
I think I vaguely remember something about adding 1 to those by proving something.
Yeah.
Something kind of like that, but I don't remember.
it's B.
Hung Sen said he would figure it out by trial and error, or more so, a special case. So here's a special case. So secant squared is 20, I'll write it under here, 25 over 16. Tangent squared is 9 over 16. Which one needs the plus 1? So that would be plus 16 over 16, which is a plus 1. And so that's where the 1 goes. Okay? That's one way to figure it out. I don't do it that way. That's okay. This is an okay way to do it. Anybody else have a suggestion? Yes?
Write them out in their fractional coefficients, because like, secant is the same as cosine, 1 over cosine, and tangent is the same as sine over cosine.
So this is 1 over cosine squared theta, and the other, the tangent is sine squared theta over cosine squared theta.
And where we came in contact with this yesterday was when we squared stuff and then divided by one of the squared coefficients, and since all the others are like both sides, I guess.
So the identity you should remember is sine squared theta plus cosine squared theta equals 1. That's the one everybody always remembers, okay? And we need to get it to have things with cosine squares in the bottom.
So you just
So you divide through by a cosine squared theta, cosine squared theta, cosine squared theta. This one is the secant squared. That one is the tangent squared. That's 1. So the 1 is added to the tangent square. Yes, ma'am?
I did it because the secant is bigger than 1 and the tangent is smaller than 1.
Not always.
Well, in this
The
particular
graph
case.
of secant looks like those kind of things, right?
Yeah, but in this
And the
particular
graph
case.
of tangent is those kind of things.
Just in this particular case.
Okay? But it is true that if you graph secant squared and tangent squared's graph is going to look like this. And secant squared's graph is going to look like that. And this starts at 0 and that starts at 1. And this one is just the same graph but lifted up by 1. Okay? Another way to do it is, at the angle 0, what's the tangent of 0? 0. What's the secant of 0?
1 over 0.
No.
That's
Secant. 1 over cosine.
1.
And cosine of 0 is
1.
1. So it's 1 over 1. So this is 1 and that's 0. So I better be adding the 1 to that side. Okay? But the point I really wanted to make was, you remember the basic identity sine squared plus cosine squared is 1. And from that, you may remember parts from 2 days ago. But 4 weeks from now, you might not remember. And what's important to remember is how you get it. And you get it by writing down the basic one, Pythagorean identity, and either dividing by sine squared or cosine squared to get one of the other 2 Pythagorean identities. Okay? All right. And then we have all these where you use the sum and difference of angle formulas to compute sines and cosines of multiples of 15 and 75 and 165, all those good numbers. And the real question I want you to go home and think about is, which integer degrees can you actually compute? You know how to do 30, you know how to do 45, you know how to do 60 by adding or subtracting 45 and 30. You can get 15, you can get 75. You know how to do all the multiples of 15. 1 second.
My pencil.
Are there any, oh, you need a pencil? Pencil. Take a pick. Oh, you want to take a pick from this end. Okay. What are the other integer degrees you can calculate? And I know how to compute easily 5 degrees. What's the smallest integer number of degrees you can compute? Is it possible to write down a nice closed formula for the sine of 1 degree? If not, can you write down a formula for sine of 2 degrees? If not, can you write down a formula for sine of 3 degrees or 4 degrees? And I know it's doable for 5. Okay? What's the smallest number of degrees you can figure out? Whole number of degrees. And the trig identities you can use are on the sheet of trig identities. So there are flipping the sign, complementary angles, supplementary angles, sums and differences. And then there are also additional ones on here for doubling an angle or halving an angle. And so if you know the sine of 45, you can get the angle of 12.5. If you know the sine of 30, you can get the sine of 15, half angles. So you can get the sine of 7.5 by using a half angle on the 15. Okay? So, but those aren't integers anymore. So what ones can you get? Sticking with doubling, halving, adding, and subtracting. Which ones can you figure out to be formulas for? Okay, so the main thing today is I want you to prove the sum and difference of angle formulas. So I first have to erase. Would you help me? You can erase this side. Thank you. Thank you. Okay, so I was going down the list. Samantha, you are up. Okay? Over here, I'm going to draw a little picture. You can tell me a formula. Here is a graph. Here is a point P, whose coordinates are A and B. Here is a point whose coordinates are C and D. Write down the distance from P to Q. Using Pythagorean theorem, probably. Don't write it too small. People have to be able to see. And you're allowed to add things to the picture if you feel it. This should just be Algebra 1, right? People who have done Algebra 1 may know it even otherwise. But that's fine. Don't need the x. We have an equal sign right there. So the distance is there. Oh, that's not quite right. Somebody want to help her? What's Pythagorean theorem say? The hypotenuse is equal to...
He got rid of your squared sign when he erased the x.
Did I?
Yes, she had x squared.
Oh,
He
that's x
erased
squared,
it.
so what's x? Ah, okay, but take the square root so you don't have the square. How do I get the distance, not the square of the distance? Then draw a square root around it. Good, now it's correct. Okay, next we have Rachel. You're coming up. Okay, here is a circle, and its radius is 1, and the angle is theta. What are the x and y coordinates of that point? Oh, I want to change the name of the angle. Alpha instead of theta. Alpha. There you go.
Wait, what?
What's the x coordinate of that point?
What point?
This point right there. In terms of sines and cosines. I'll draw a line. You need to know what this side is. distance x and this distance y. What is x over 1? Okay, so what's the x coordinate? It's right here. What is x equal to? Write that in.
You're just out.
And now what's the y coordinate?
It doesn't necessarily it doesn't have to. I know. But it's not using very soon.
Okay. Everybody understand why that's true?
Yes.
No, not really.
No, I'm trying to explain to him.
All right.
If you look-
What is the definition of the cosine of this angle? Adjacent over hypotenuse, right?
Yeah.
So the cosine of the angle is x over 1.
Yeah.
X over 1 is just x.
Yeah.
The sine of that angle is y over 1, which is just y.
Yeah.
So if x is cosine and y is sine of alpha, then there's the x, there's the y. That's how you write down coordinates. You put the x coordinate and the y coordinate.
So the x coordinate is cosine.
Cosine of the alpha of the angle and the y coordinate sine of the angle. Any other questions on that? Okay. Rachel, got another question for you. Here is the angle beta, and I want that one. What are its coordinates? You don't have to come up, you can just tell me. Here's the point, and its angle is beta, so what are its coordinates? Okay. And you're on. Ben. Okay, Ben? First of all, what is this angle? Here is alpha. Here is beta. What is this?
Be the sine of alpha.
I don't want any angle. I just want the angle. No sines and cosines.
It would be alpha minus beta.
Okay, so that angle there is alpha minus beta. Okay. Now, the real question I have for you, this is a point P, this is a point Q. What is the distance from P to Q? Over here, if the point's coordinates are AB and the other point's coordinates are CD, there's the distance formula. Here we have the point is cosine of alpha, sine of alpha, and cosine of beta, sine of beta. I simply want you to write out the distance formula for these 2 points. Write it up there, put an equal sign after the word distance. Okay, you can recopy it if you feel like it. Equals. Very good. Any questions about that? Here's the guy. Any questions? All right. Now, that is this distance. Now, the trick that we're about to do is to rotate that angle. And here is another picture. It is also a circle of radius 1. And now I measure the angle from here to there and make this be the angle alpha minus beta. So that angle is the same as this angle. Okay? It's not that, it's not this, it's the angle between these two rays, but rotated down. Okay? Here's a point. What are its x and y coordinates? Need a little more space. So, who's next? We are down to Annie. You're up. Oh, Annie, there.
Wait, she lost on the list.
No.
What? Wait, did you skip?
No.
Did you skip like 5? Yeah, I think you skipped Tony.
Hey.
Oh,
No, it's-
Anastasia and Tony are out of alphabetical order.
Oh.
Because they added the course after I
Wait,
made
fine.
it. What are the coordinates of this point? Just think about what how we found those.
This is I don't know.
Sure. Yeah. You're done. All right. Any questions about that? That was easy. All we did is replace the alpha by alpha minus beta in both places. Okay, now I have one to ask everybody. What are the coordinates of that point?
X.
1.
Something comes 0.
1, 0.
Something comma 0. What's the radius of the circle? 1 comma 0. Okay, that was too easy for me to bother picking on somebody. Now it's Hung Sen's turn. Find the length of this chord. What's the distance between this point and that point? Distance. Equals. So get started. Here's the x coordinate, y coordinate, x coordinate, y coordinate. Have a different pen. Only a little bit of notation. It's sine of the quantity alpha minus beta, all squared, so another set of parentheses is needed. Okay? Okay. Now, we have this distance, and we have this distance. One of them is here, the other one is here. What can you tell me about those two distances? They're equal, because the angle is alpha minus beta in both cases. So those are equal. So we are going to set them equal. We're doing capitals. So I'm just going to copy those two things down over here. The square root of cosine alpha minus cosine beta all squared plus sine alpha minus sine beta all squared is equal to the square root of the square of cosine of alpha minus beta minus 1 plus the square of the sine of alpha minus beta. Okay, who's next on my list? Oh, we got a good person who can do it. Parth. Simplify that. How do you get rid of the square roots?
Square both sides.
Okay, you do that with an eraser.
Squaring things with the eraser.
Then you both have to square root.
Okay, we squared both sides. You always have to be careful. When you square both sides, you got to get an absolute value. If anything is negative inside, you got to be careful about it. But all of this is positive stuff. Okay, you need to square this out. So first, let me review it for anybody who hasn't done it. A plus B squared. Do my non-algebra people know how to do that? That means A plus B times A plus B. Have you learned distributive rule?
Yes.
So it would be 2A plus 2B.
Where's 2?
2A.
No, it's A times A.
Yeah, that would be 2A.
No, it's
No.
A. Hey, that's
It's 2A squared. Good. Keep going. Go on, Mark.
B squared.
Plus a B squared. That's this times this and this times this. What else you got?
The
This times that
plus A, B,
plus this times that,
plus BA.
which is the same as AB.
So B.
Okay?
Or-
Now, do you remember Pascal's triangle?
Yeah.
There's the 1, 2, 1 of the second row of Pascal's triangle. If you cube it, you get a 1, 3, 3, 1 for coefficients.
Wait, what's
Okay.
Pascal's triangle?
You remember? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1.
How do you get those?
Each one you add up the numbers above it.
Finish.
And that's one.
5 minutes on that.
Which we had to do.
These are the coefficients in this formula. Okay? If you were cubing it, you would use these formulas. So he's squaring. So the A here is cosine alpha, the B is cosine beta. Go ahead and square. I want to make sure people aren't lost as the algebra gets done. Okay, so there he squared out this first piece. Now he's working on squaring out the second piece.
Oh, sorry.
Oh, wait, you can't use it on,
It's the first one squared, the second one squared, and twice their product. Okay? And if there's a minus sign between them, the product gets a minus. Right?
Was there a minus?
No? Oh, there is, yes. So you got a minus there, minus here. Okay. Equals. Square out the other side. Michael, you better pay attention because you're next.
Yes, Mike.
You slip from alphas and betas back to A's and B's. Yeah. Prove what? There may be a way to do it with parallelograms, it's the way I like to do it. And if you should have another way, I'd be happy to see. Show me next time. Okay, so there we are. You can go back to your seat and hand the pen over to Michael, and Michael can come up here and continue to work on it.
I'm ready for another job.
All right. Now I want you to simplify it further. So in this top line, what does sine squared alpha plus cosine squared, I'm sorry, here's sine squared alpha and a cosine squared alpha. What do they add up to? Write a 1. And put a check mark over the two terms you used up. Okay, there's a cosine squared beta and a sine squared beta. Okay, and now write down what you have left. That's not a times. You have this whole thing. You have this bigger. You're shrinking. Handwriting. Alpha is drawn starting at the top right and come down there. Beta is drawn starting at the bottom and going up. Okay? Looks much better. Equals. How can you simplify the right-hand side? This stuff. Okay. Where'd you get a +1? And where'd you get? Okay, yes. Mm-hmm. Okay. You can go back to your seat. Next, we have Anastasia. Come on up.
Oh, Anastasia.
Yeah, I remember.
What cancels from both sides? Just cross them out. What's added to both sides? It's the same. This is your day. Huh? Yes. It's 1 plus 1 minus 2 cosine alpha times cosine beta minus 2 sine alpha times sine beta equals 1 minus 2 cosine alpha minus beta plus 1. What cancels?
Oh yeah, I don't have anything.
Okay. And now, anything else cancel?
More than 2 cosine beta.
No, because that's cosine of alpha minus beta, not cosine of alpha. Well, what is your coefficient? -2? Is there a coefficient minus 2 on the other side? Not the alpha, not the sine alpha, just the minus 2 cancels. And? Okay, and what are you left with? Write down what you're left with. Cosine alpha times huh?
Everything works out nice.
Okay, now she made one small mistake. Anybody see it? Move over so you're not standing in front of it so everybody can see. And try to, can you find your own mistake? What did you cancel? You canceled a 1 plus 1 from both sides.
Oh, yeah.
Then you canceled a minus 2 from both sides.
Oh, so you're
That
right.
did
Do
that.
you see it yourself? You want somebody else to tell?
Oh.
Got it. Any questions? And that is the cosine of a difference formula. If we want the cosine of a sum formula, you replace beta by minus beta everywhere. And that won't flip the sign here, it will flip the sign there, and it will flip the sign inside there. And so cosine of alpha, let me write that one down. Cosine of alpha plus beta is equal to cosine alpha, cosine beta, sine alpha, sine of minus beta, and the minus sign comes out front because sine of minus beta is minus sine beta. So we have the formula for the cosine of a sum and the formula for the cosine of a difference. Okay? How do we get the formula for the sine and cosine of of the sine of a sum and difference instead of the cosine?
I got nothing.
One second. Yes. Who said yes?
This square alpha plus beta plus the cosine square.
You're using squares. That makes it much more complicated. Sine of pi over 2 minus theta is the cosine of theta, right? And the cosine of pi over 2 minus theta is the sine of theta. That's the complementary angle formulas, right? So if I would like to know what the sine of alpha plus beta is, it is the cosine of pi over 2 minus alpha plus beta. That's just using this formula backwards and replacing theta by alpha plus beta, right? What do I do inside here with that minus sign? Distribute it. So I get rid of the parentheses and put a minus on both. And then I can group them like that instead. And now, that's the cosine of an angle minus beta. But we have that over here. Okay? So, let me write that down again. Cosine of a sum is equal to cosine minus sine. So, I'm going to change the letter. Gamma minus beta gamma minus beta, gamma minus beta flips the sign. So there is the formula for cosine of gamma minus beta, but gamma is now pi over 2 minus alpha. Right? So I'm going to write that down. Cosine plus sine, Okay, so the beta has a minus on it just like here, so I just write in the betas. The gamma has to be replaced by pi over 2 minus alpha. Pi over 2 minus alpha. Pi over 2 minus alpha. What do you know about the cosine of pi over 2? Yes?
Is it plus sign or minus?
It's a minus inside. Oh, where? Here?
Yes.
I took
Oh.
this formula, which has, if it's a difference there, it's a plus there. Okay?
Oh.
That's from this top one that you and Michael derived. Okay? And Anastasia. Three of you derived. And now I'm taking that formula, I change the alpha to be gamma, so it slows me down and helps me do my substitutions clearly. And now the gamma had to become pi over 2 minus alpha. Now, what do you know about cosine of pi over 2 minus alpha?
It's equal to sine of alpha.
Oops. What do you know about the sine of pi over 2 minus alpha?
Cosine of alpha.
So we have sine of alpha plus beta is sine alpha, cosine beta plus cosine alpha sine beta. And we have cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And we will read it together again. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. That is trig wrapping, okay? And these you memorize. You shouldn't have to rederive those, but I wanted you to see that they come out of calculating distance formulas. Now we can also get it another way, and this is a homework assignment. Write it down, and I think I will collect this one. So let me explain what you're supposed to do. Okay, here is a circle, a unit circle. The radius is 1. Here is an angle alpha with alpha positive. Okay? The coordinates there are cosine alpha sine alpha. Same as it was before, right? Here is an angle minus beta with beta positive. I explicitly wrote the minus sign down. Okay, so beta is a positive number. And its coordinates are cosine of minus beta. What do you do with cosine of minus beta?
Positive beta.
It becomes a plus beta. Sine of minus beta. What do you do with the minus?
Negative sine.
You pull it out front. So here we have 2 points, right? You can write down the distance formula. So I'll call this P, I'll call this Q. You can write down the distance from P to Q equals square root of stuff. Write that out. Now I'm going to take that same picture and rotate it. So here's the circle. Here is the angle alpha plus beta. Here's beta, there's alpha. the total angle is alpha plus beta, right? And so the length of this chord is the same as the length of this chord. So again, it's radius 1. It's that chord we are looking at. The coordinates of this point are 1, 0, just like last time. The coordinates of this point are cosine of alpha plus beta, comma, sine of alpha plus beta. Okay? And so let me give names to that. This we'll call point R. This we'll call point S. We can find the distance from R to S. Write that out. Those two distances are the same. So take these two things, set them equal, just like we did over here, set them equal, multiply everything out, cancel whatever is needed, and I believe you will come up with a formula for cosine of alpha plus beta, which should be the usual formula. So that's another way of deriving it, and since it's a little different, I'd like you to try doing the algebra needed to simplify everything to get it down. So just redoing it, yes, just give you practice understanding the process, okay, yourself. So everybody has to turn that one in, okay? I do. Turning pencils back to me afterwards as you. Do you like to see the eraser size? That doesn't have a good point. It'll work? Okay. Just put them back in my box over here when you're done. Okay. So, the important two identities to remember, well, there's a group of them. You have to know sine and cosine of a negative angle. You need to know sine and cosine of the complementary angles, which I erased. Sine of pi over 2 minus theta is cosine of pi of theta. Those ones where you do complementary angles. Those are easy to remember. Other things like supplementary, you can get it out of the sine of a plus b and a minus b. So let me see if we can get one of those. So we have a formula for cosine of alpha plus beta is cosine, cosine, sine, sine, alpha, beta, minus alpha, beta. So there's the cosine formula. Suppose you need the cosine of pi minus beta, the supplementary angle formula. Well, you might remember it, and you might not. Okay? Pi over 2 minus beta, you're not going to know immediately. That's sine of beta. Right? But this you might not remember, so it is easy. Cosine, pi, cosine, beta, minus sine, pi, sine of minus beta, flips the sign. So there it is. Now what is cosine of pi? These basic angles, you ought to know the sine and cosine.
2 sine minus theta.
Here's a circle. Pi is over here. Cosine is the x-coordinate, assuming it's radius 1. So what is the x-coordinate over there?
-1.
-1. Cosine beta. What is the sine of pi? What is the y-coordinate here?
0.
0. So this is minus cosine of beta. So you can re-derive the complementary angle and supplementary angle formulas out of the sum and difference formulas if you forget them. Okay? You do need to remember the formula which says sine of minus theta is minus sine theta, and cosine of minus theta is cosine of theta. You've got to remember those. Okay? What other identities do you have to remember? Sine squared theta plus cosine squared theta is 1. The ones with tangent squared and secant squared and cotangent squared, cotangent squared, you can rederive from these, so you don't need to memorize those separately. Okay? And then there's a whole slew of additional identities that can be derived from these two formulas. Sine of alpha plus beta is sine cosine, cosine, sine, alpha, beta, plus for the sine identity. So there's 2 at the top. There are a whole bunch of other identities we can now get from those 2. And Tony, I haven't called on you. Sine of 2 alpha. How are you going to get sine of 2 alpha out of sine of alpha plus beta? Yes. So write sine of alpha plus alpha. Okay, proceed to do it. Plug it in here, in the top right. And can you simplify that any? So equals, keep going on the same line, equals. And you just derived the double angle formula for sine. Any questions about that? And we also want to know the cosine of 2 alpha. And my assistant now is...
Julian!
Haven't I called on Julian?
No.
Did I skip you? Where are you?
I don't know which one you meant.
Yeah, there you are. Look, I skipped Julian. Okay. Here you are. So, what are you going to do on this, to this line? I was all ready to start over again. Okay, can that be simplified any?
Yes.
And he's incorrect about his simplification. No.
And he never skips those.
It's not equal to something else. This is just wrong. Cosine alpha times plus cosine alpha is not 2 cosine alpha.
I can't see that.
Gotta write bigger. Okay, and now how do we write cosine of alpha quantity squared? There's another notation for that. Equals cosine squared alpha minus sine squared alpha. Thank you. Any questions about that? Yes. This means sine of alpha quantity squared. Okay? It's just people write it with the square on the function. Okay? All right, now that's one identity for double angle for cosine. There are actually two more. There are two more, and they come from knowing sine squared alpha plus cosine squared alpha equals 1. And so cosine squared alpha is equal to 1 minus sine squared. So this is 1 minus sine squared alpha minus sine squared alpha. Did everybody see what I did? Watch. Tony, did you see what I did? No. Okay. What did I do? I had this identity that Julian derived up here, and for cosine squared, I replace it by 1 minus sine squared. So 1 minus, how does this simplify? 1 minus 2 sine squared alpha. Okay? There is another version of it. You write down the cosine squared alpha minus, and instead of sine squared, you use the Pythagorean identity again. 1 minus cosine squared alpha. Got to be a little more careful with that one. After you distribute, how does it simplify?
Minus 1 plus cosine squared alpha.
Minus 1 plus what?
Cosine squared alpha.
There's one of
2
those.
squared. 2 cosine.
2 cosine squared alpha. And so for cosine of 2 alpha, there are 3 versions. That, and that. And they are all useful for different purposes. Okay? And so one should know all 3 of them. If you look at the page of identities, review of tree, negative angles, complementary, supplementary, sum of 2 angles, difference of 2 angles, double angle formulas. We got, these are the double angle formulas for sine and cosine. Okay? Also, there are square formulas. So you would like to know a formula for sine squared alpha and cosine squared alpha. Sine squared alpha appears right here. Cosine squared alpha appears right there. You just have to solve for them. So I will do it. Let's start with this one. Cosine of 2 alpha is 1 minus 2 sine squared alpha. I add 2 sine squared alpha to both sides. Cosine of 2 alpha plus 2 sine squared alpha equals 1. I subtract cosine of 2 alpha from both sides. Minus cosine of 2 alpha comes off of both sides. Now what do I have to do to it? Divide by 2. So I divide by 2, and I come up with the formula 1 minus cosine 2 alpha over 2. Along with what the other problem I gave you for homework, I want you to do the following. Take this identity and solve it for cosine squared alpha to figure out what the other identity is here. Okay? What goes in there?
Second homework.
Second homework assignment.
Can you
Okay? I just did this one over there by writing down cosine of 2 alpha is 1 minus 2 sine squared alpha and solve for sine squared. You set cosine of 2 alpha equal to 2 cosine squared alpha minus 1 and solve for cosine squared. Okay?
So it's cosine 2 alpha equals